Lesson 1-9 is about graphs, and we did some work with graphs on Friday. So this isn't really, it's more kind of an extension of that, and we're just going to talk about a few things in a little bit more depth. First of all, when we have a coordinate plane, the dependent variable is always graphed on the y-axis, and the independent variable is always graphed on the x-axis. Okay, and how do you tell the difference? Well, the dependent variable depends on the independent variable. So let's go to the next slide and take a look at an example of what a dependent and an independent variable would be. Okay, if I were to take a look at how many ice cream cones are sold, and also to look at the temperature outside, I could say that one of these things depends on the other, okay? The number of ice cream cones sold depends on the temperature outside. The temperature outside does not depend on the ice cream cones. So we're going to label the number of ice cream cones sold as the dependent variable because it depends on the temperature outside, which would be the independent variable. So if I were to make a graph of how many ice cream cones were sold when the temperature was a certain temperature outside, then I would put on the y-axis the number of cones sold, and on the x-axis I would put the temperature outside. Okay, and I should always put some units on it, so let's put that in degrees Fahrenheit. Okay, so dependent depends on the independent. So in this case, ice cream cone sold depends on the temperature outside. And the last thing we need to go over are simply bar graphs, line graphs, and circle graphs. You've done this before too. Circle graphs are sometimes called pie charts. So a bar graph compares different categories of data. I might poll the class and find out the favorite pizza topping and put that into a bar graph. A line graph would be something that would show how data changes over time. For instance, it might be something like as the student's age increases, what happens to the amount of screen time that they have, or something like that. So a line graph might be useful for something of that nature. It's also helpful when you're trying to make predictions about the future when you don't have any data yet. But based upon trends in the past, you can maybe predict what might happen in the future. And a circle graph compares parts of a set of data as a percent of the whole, and the sum of the percents should always add up to 100%. And as an example of that, if we were to look at a graph, we should be able to interpret the graph. So in other words, if we have a graph that shows the flight of a spaceship, and in the altitude that the spaceship is at over the time of its flight. Okay, so time might be in, let's say, hours, okay? The altitude might be in kilometers above the Earth. If I were to have a graph that looks something like this, what this might tell me is that the space shuttle first rises in altitude quickly, and then it plateaus and stays at the same altitude for a while, and then comes back down rather quickly. Okay, so that's an interpretation. When I say to be able to interpret a graph, be able to look at what's happening on the graph and be able to describe in words what is actually taking place. So there'll be some of that in this lesson as well. So that's about it for today, and hope you guys have a great weekend.